session. So as said, I'm Dr. Simon DeVette. I'm running labs here in the Department of Physics and Atmospheric Science. These are introductory labs for mostly engineering students, about 70% engineering students, 30% science and random others. I've been teaching this lab for, 11 or 12 years now, something like that, in person, of course. So this is our first year doing something online or remote. So I want to talk a little bit about what we did and what worked and what didn't. So, of course, the big question that we all had is that classes went online, and then, what do we do now? In the spring, it was just a little bit of a panic. What can we possibly do? We just excused students. But now that September rolled around, we were actually able to make some real changes. So normally labs are done in person. We've got a nice big lab room. We have all kinds of really nice equipment that students use. Students get together in groups. We walk around. We help them. It's really good. But all of that is out the window. We can't gather together. We can't have expensive equipment. So the question is, what's left? What can we possibly do with these labs? So this made me sort of look back and try to evaluate, what's the point of these labs? I've been teaching this for over 10 years. What's the purpose? And there are arguably two purposes to a physics experimental lab. One is, of course, learning physics, and the other is learning experimental skills. And what I decided pretty early on is I had to emphasize the second of these 2 points, because after all, we're still teaching physics in lecture. That doesn't change. But the experimental skills only exist in the lab. So whatever we do to this remote lab or online lab, we have to maintain those experimental skills that we're teaching. So that has to be our focus. So this is exactly what I said. So for example, our first experiment of the year, when we're traditionally in person, is called projectile motion. So, students shoot a little ball, goes flying through the air, they measure the range, they graph it, they use it to calculate speed, and so forth. So they're learning all about projectile motion, but in practice, what that lab is actually teaching them is about graphing, or dealing with nonlinear data, or using that to analyze it and calculate something new. So that's a real purpose. Our Newton's second law lab, we've got big carts that they pull down the hallway, they drop sandbags, measure accelerations and so forth. But the real purpose of that is learning about uncertainties and error propagation. How do you get reasonable results from what is arguably a extremely imprecise experiment? So what we need to do is we need to focus on the second half of both of these statements. I can throw away projectile motion, but I need to keep graphing. I can throw away Newton's second law, but I need to keep the uncertainties and error propagation. So that was my approach for this lab in September. So these are the requirements. This is what I decided we absolutely had to do. First of all, we have to teach the exact same skills, or not the exact same skills, but as close as we can come. So error analysis, that's something we need to keep teaching. Even if Newton's second law is gone, we still have to teach about error propagation, uncertainties, and so forth. Even if we don't do projectile motion, we still have to teach about nonlinear data. We have to talk about models. We have to talk about a lot of other things. There's a whole lot of different lab skills. So the first thing I did is just go through all my labs and more or less just make a list. Here's what we're actually teaching. Here's what we need students to actually understand from our labs. And it's not the physics, it's the lab skills. We can come up with new physics. Second thing, of course, is that these are remote labs, so they have to be done at home. And if they have to be done at home, first of all, they all have to be done by themselves. Students have to be able to work solo. When we are in person, we are usually working in groups of 2 to 4 students. We can't do that anymore. For one, we're just physically not allowed to get together anymore. And also, students are just isolated. I teach a lot of international students. They're spread all around the world. I got a student in Barbados, I believe, who is in an extremely strict lockdown, is physically not allowed to leave their house anymore. And it's been like that for weeks. Not much you can do about that. So we have to be able to have experiments that can be done solo. They have to require no specialized equipment whatsoever. We can't even expect somebody to go out and buy something that costs $10. That's no good. So everything in the lab has to be done using things you just find around the house. Which means like we can't even expect students to weigh something because not everybody's going to have a scale. So our only expectations are that everybody has a ruler and everybody has a stopwatch, because that's just built into any phone these days or any computer. So that's our plan. Everything has to be household items, cheap, easily accessible for everybody. The other thing is, of course, I can't reuse anything because, as I said, all of our nice old labs use fancy specialized equipment and none of that's available. So this project is not going to be about translating our old experiments to this new format. This is going to have to be about building 6 new labs, 100% from scratch, labs that have never existed before. So I'm building the entire lab program from the ground up. So that sounds like a daunting task. So let's see what we did. Yeah. So first of all, when we teach the lab in person, of course, we're in a room that has myself and a couple teaching assistants, and students are working in groups. So there's lots of ways for students to get instruction. We give them written instructions, but nobody ever reads it. Like that's just always the case. So in this case, we had to give written instructions in a way that is self-contained and standalone. So a student can just get these written instructions, do everything on their own. Now, in theory, that's how it's always worked, but in practice, we'll see. So I want to talk a little bit about how I actually provided instructions. So this is a brand new experiment this year, experiment about friction. It's very similar to a demonstration that we do in class. So the first thing is we make reference to lecture videos. This year, all of our lectures were pre-recorded. They're actually lectures that I recorded, so it's my own voice, on different topics. We decided not to do like hour-long or 2-hour-long lectures. We broke them up into tiny little segments, little 5-minute, 10-minute segments on specific topics. So for every lab, I just say, here are the half dozen or however many lecture videos that are relevant to this particular experiment. So watch these videos and you'll know everything you need to know. Again, labs need to be self-contained. So in addition to these lecture videos, I can't expect everybody to just know all the physics because they're not going to. So I provide them everything they need, all of the theory, free body diagrams, equations, derivations, whatever else is necessary, we give to the students. So this lab, these couple pages of written instructions should contain everything they need. They don't need to open any other document to complete this experiment. Here's some other things that I did. One thing I talked about earlier in this presentation is about lab skills. I said that, every experiment has a skill, nonlinear data, error analysis, whatever else. I want to be explicit about this. I don't want students to have to guess why they're doing an experiment. So every lab, I explicitly talk about what is the lab skill? What is the purpose of this experiment? I don't know if students read it or not, but I hope that they do. We often come back to this later in the experiment. First, we have, our equipment that's provided. I'll talk a little bit about how students submit their work, but I will say this, that when I give the instructions, because these are online labs in an online format, I can get away with things that I can't do in person. And our lab manual in person is printed. Our online lab manual is online, so I can use color, which is kind of fun. I can highlight things, which is great. So one thing I did is every single thing that a student actually needs to submit, every word that they have to write down, every number that goes in a data table, every photo that they need to take, I highlighted in yellow. So there's absolutely no way that a student can do this experiment and miss something. Everything that they have to do is explicitly stated. Another thing I did, and this is something I actually introduced last year in person, is something we call waypoints. So the idea is that as a student does the experiment, they reach a point and they want to know, hey, am I doing this right? Am I doing this wrong? We don't know yet. In person, we help them. When we're teaching this lab in person, student reaches a waypoint, they put their hand up, we come over, we look at their data, we say, yeah, it's good, it's bad, whatever. We help them out. Of course, we can't do that anymore when it's online, so I introduce these waypoints, the idea being that when you reach this point, it's a time to stop, look at your data, and we actually tell the students what to expect. So in this case, I tell them, you're doing an experiment 5 times, you should get about the same result each time, probably within about 5 degrees. So if you find one of your experiments is like 10 or 20 degrees off, maybe you made a mistake, you need to go back and revisit that. In some cases, I even give them numbers. So like I know a graph should have a slope of about 4. I'll just tell them that. I'll say like, hey, your graph should have a slope of around 4. If you get something much bigger or smaller, go back, double check it, make sure you know what's going on. The idea being that a student should not be able to be on the wrong track for too long. They should be able to get themselves right back on track as soon as possible, check their own work as they go along. So those are waypoints. Something else I added, which is just sort of fun, is a little bit for the keen students, the ambitious students, basically saying that, hey, these experiments are pretty simple. If you're curious, if you want to do some more stuff, here's some other ideas, some other things that you can do if you want. These are not graded. These are beyond the official scope of the lab, but hey, try some other things. See what happens when you do these other experiments. Come up with something on your own. And I've had a couple students contact me about this, some keen students who've come up with some really clever ideas. So very proud of them. So that's what the instructions look like. These are the written instructions. But in addition to written instructions, we also have instructional videos. So for every lab, I produce a video. It's usually short, just a couple minutes long, 5 minutes or so. And it's just me in front of a camera doing the experiment. I show them all of the apparatus that they need, everything that they need to complete the experiment. And then I actually do the experiment for them. So in this screenshot here, I'm doing the experiment about friction that involves just putting a rubber eraser on an incline, tilting it, seeing it when it starts to slide. So on camera, they get to watch me do it, and they get to see me do the measurements. I do all of these just at home because they're going to be doing it at home as well. Everything is done in one single take, so no edits. It's just me sitting in front of a camera for 5 minutes. In part, just to show that, this is completely honest. Like, you want to watch me do an experiment? Here I am. I'm doing an experiment. I'm collecting real data. I'm not trying to cheat in any way. And the other big reason is just that I'm pretty lazy, and it's a lot easier to record a 5-minute video than it is to record a 45-minute video and then cut it down to 5 minutes with editing and retakes and all that. So, why not get it done in one shot? I also try to give students a lot of reassurance when I do this, to basically say like, hey, look, I did this experiment for you in about 2 minutes. I think that you can do this on your own without too much trouble. I think you should be able to get some nice data here. So this is what the instructions look like. We've given them written instructions. We've given them video instructions. Now I want to talk about the other side of the equation, so what we expect students to do. So what I've done, there it is I've created worksheets for every experiment. And the main purpose of the worksheet is just to keep everything in a common format. So it turns out Microsoft Word actually has this lovely feature. It's hidden under developer tools, where you can turn a Word document into a fillable form. And what that basically means is that the majority of the document is locked, so students can't edit anything, they can't change anything, but you can allow them to type text somewhere or to attach photos or something like that. So that's what I do for every experiment. I create a fillable worksheet that has everything that they need. So some things might be photo submissions. You see one of those in the middle of this page. That would be for students to take a photograph of their apparatus, for example. We want to make sure people are actually doing these experiments. So, you've got to take a picture of your eraser sitting on the ramp. You can't just take it for granted that they did it. This is also good for calculations, anything where a student actually has to show their written work. We can do that. It's good for graphs, because in our lab, all graphs are hand-drawn. But even if you do it on a computer, you need to be able to submit images. And the other thing is text submission. So for example, this is a data table for the friction lab. They enter in all of their data, all of their numbers. It is easily formatted. We don't have to worry about messy handwriting. This is extremely easy to grade. The last place it appears are our discussion questions, where we can just give students space to answer short answers. Just type in text. And it worked really well. It worked really well 90% of the time, 95% of the time. Some people struggled at the beginning, but we got it figured out pretty quick. So this works very nicely for us. So once students have done this, once they've filled out their worksheet, we have our submission. So the documents that they create, we can just save them, PDF or a document file. Brightspace just has an assignment submission, file submission. We allow them to submit one file per student, but we only grade the most recent submission. So if a student submits a report, it realizes they made a mistake, they can just resubmit it. The old one is gone. The new one is the only thing we see. I don't have it mentioned here on the slide, but I do give students lots of time. So we provide the students with all of the instructions, the video, the written instructions, the worksheets, and so forth on a Tuesday. And then the lab itself is due 2 weeks later on another Tuesday. Even though students have 2 weeks to do the report, most of the experiments, I would say, take maybe an hour or two to submit. So they don't have a tight schedule. They can follow their own schedule. If they're busy, they can start a little bit later. They can start early if they want, although none of them ever do. So it's been working pretty well. They have right up until midnight to submit, and I'll talk a little bit more about what we saw there. So these are how the submissions work. It's worked out great so far. They've submitted 5 labs already. So what I also want to talk about is the other side of this, which is interacting with students. When we normally have our lab in person, it is the students doing their little experiments at benches with equipment, but there are also 2 teaching assistants and myself in the room for the full 3 hours. We're walking around, we're looking over people's shoulders, we're giving them feedback if they do things wrong. We are periodically checking the results. Whenever they reach one of these waypoints, they put their hand up, we come over and check their results, and until they've done it right, they can't move on to the next step. So we provide an enormous amount of help, but now, of course, we're spread out. We're all around the world. So the question is, how do we do this? The labs are meant to be closer to a tutorial than to a test. In other words, we want students to do well. We want to answer questions instead of letting them get a wrong answer. So if they don't know what's going on, we need to get them on the right track. So the question is, how do we do this remotely? So we've got a couple things. One is I've been running live help sessions. So I do this 4 times a week, twice in the morning, twice in the afternoon to accommodate students in different time zones. It's all been run through Collaborate Ultra, which I think many of you have used. If you haven't, it's a lot like what we're in right now. It's a lot like Teams. And students can just drop in. It's entirely optional. It's just me with a webcam pointing at a sheet of paper, and students can ask questions. I can solve these things on paper. We can provide them with feedback. I'll talk a little bit about the outcomes. I will say that it's usually pretty busy. I had office hours or help sessions yesterday, and I think I probably had maybe 20 students show up. But it is just the same 20 students again and again. So out of 500 students, it's just the same faces every single week. So I'll talk a little bit about that at the end when I talk about the pros and cons. The other thing we provided is a discussion board. This is where students can just post questions and I'll answer them. In theory, this helps prevent me from having to repeat myself. You know, if a student asks about uncertainties, answer it, and then hopefully the next student with the same question can just read that answer instead of asking again. In practice, I am just answering the same like 5 questions again and again and again, but so be it. I also have email. Students can always email me, although I try to send them towards a discussion board when possible because it's a little bit more of community teaching here. I also want to talk a little bit about grading. So we still need to grade all these reports. We have about 500 students. all submitting a lab report. We need to be able to get the grades back to them as quick as possible. Everything is done online through Brightspace. We are using rubric grading. So for every experiment, I break the lab into different criteria. So for this one, for example, students had to take a photograph of their eraser in the ramp. They had to fill out the data table. They had to do calculations of angle. They had to find the uncertainty in angle, and so forth. Every one of these criteria, I just gave 3 different levels. It's either good, full marks, some concern half marks, or just no good at all, 0. And this is how my TAs mark. They see the lab report on one side of the screen. They see the rubric on the other screen. They just go click, 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 assigning grades. They can provide feedback if somebody gets less than a 1, or if they have something they need to provide. Everything gets tallied automatically. It all automatically gets submitted to Brightspace straight into the gradebook, which is really nice. It actually saves me a whole lot of work. And students also get instant feedback. Like as soon as we publish this, boom, they can see exactly what grade they got in every one of these 10 criteria. They see all of their feedback instantaneously, and a lot of them actually read their feedback right away. So this was wonderful. Very happy with this rubric grading. I've never done anything like this before, but so far seems to be a success. So that's basically what we did. To quickly summarize, we have to come up with entirely new experiments. We give written instructions. We give video instructions. Students do the experiments at home. They fill out worksheets. We provide them with help. The worksheets get graded by teaching assistants with rubrics, published online, 100% online. So this is the success story. First of all, I don't have a bullet point for this, but students seem kind of happy, which is nice. Or at the very least, I have received no negative feedback about the lab so far. Maybe they're just being shy, but I think it's generally positive. I just came from a couple different meetings, a science committee meeting and just our departmental meeting, and we've been hearing a lot of feedback from students that they've been having trouble with experiential learning in science. In other words, just running labs in online classes. How do you get something out of a lab? We haven't gotten those complaints in this course, so I don't know, maybe it's working. I hope it is. We'll see. So here's what worked from my perspective. First of all, students are doing the work, which is nice. They're submitting good work. They're completing labs. Stuff is being submitted. It seems to be going fine from my perspective. I've not seen any disaster stories here, or very few. Like I said, we managed to cover all of our important lab skills. Even though this was a 100% lab built from scratch, never existed before, we still covered graphing, we still covered uncertainties, we still covered, discussing simple models, everything like that. The other thing that's lovely to see is students are actually applying these skills. So in one of the first experiments, we taught them all about uncertainties. In a later lab, we don't explicitly tell them to do this, but I see that they are using the techniques I taught them in the first lab on experiment 3 or experiment 4 without me even asking them. So they're actually learning this stuff, and that's wonderful. I mean, I hope that they're learning it, but it's delightful to actually see it happening. So that's great. They're actually learning from this. Online grading is real fast. So using this rubric, like I said, click, 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 add a little bit of feedback. You can go through a lab report in a minute or 2 and provide good feedback and give them a good grade. It's wonderful. When you're grading on paper, you can still grade, but it takes, 3 or 4 minutes at best, 5 or 6 if you're having a hard time to grade a paper report. So it's nice and quick. It's nice and efficient. My teaching assistants, they can just do it on their couch. The rubrics are really nice because it provides detailed grade breakdowns. When we grade on paper, a student might get 8 out of 10, and they'll be able to look at their feedback. But I don't have it recorded anywhere. I just have 8 out of 10. I don't have, 1 out of 1 here, 0.5 out of 1 here, different categories. So I have access to more results. I can see which aspects of which experiments students are struggling with. And that's wonderful. It's nice to have that feedback. Also, and this is something for the administrators listening in on this, it's also real cheap. My TA hours were cut in half because they're only marking. They're not physically in the room anymore. We don't need equipment anymore. We don't need space anymore. The lab is not, what it used to be. I like the in-person lab, but hey, if you got to save money, we are saving money on this, and that is a concern these days. So that's what worked. Not everything worked. So of course, some downsides. First of all, grades were a little bit lower because we aren't physically in the room able to walk them through it. Students are more likely to just mess up and submit poor work. When we're in person, basically nobody ever gets a lab grade below 50%. Now, it's not common, but it's certainly not unheard of. I'd say like 10% of the students in any particular lab are failing that experiment. And those are students who are just completely not following the instructions at all, and also never asking for any help, never contacting me. The other thing is that there's a surprising number of students who just don't do anything at all. So we have 500 students in the lab. The last experiment that was due a couple weeks ago only had 400 students submit anything. Those other students, they didn't run out of time. I can go and look at their Brightspace. They never looked at the instructions. They never downloaded the worksheet. They never watched the video. These are students who just didn't do anything. They didn't even start. They didn't even try. So this may be a function of online teaching. Maybe they're overwhelmed. Maybe they don't even exist. I don't know. But there's 10 to 20% of students who just don't do anything any given week. Even though we give students 2 weeks to do things, we actually have a lab that's due tonight. And out of the 500 students, I think we only have about 150 submissions. So the majority of submissions come on the very last day. In fact, I would estimate about a quarter of the submissions come in the hour before it's due. So it's due at midnight. I'm going to get a huge rush of them around 11 p.m. And in every single experiment, there's about a dozen students who just miss the deadline by like 5 minutes and email me, and I'm a real nice guy, so I just give them an extension. I'd say, okay, fine, just submit it tomorrow. I'll grade it. No problem. I don't care. Like I said, we provide a lot of help. We have our discussion board. We have my live help sessions, email, and such like that. But it's really just like the same couple dozen students who I see again and again. When we're in lab, because we're checking everybody's work, every single student, without exception, gets talked to by us. We have a conversation with every single student. Nobody can slip through the cracks. In this case, because it requires students to be proactive, they have to come to us instead of us going to them. Students do slip through the cracks, and that is why we have some students submitting poor work and probably some students not doing anything at all. So that's a shame. The other shameful thing, or the thing I miss, is a lack of community. When we're physically in the same room, we're all doing stuff together. Students are chatting with each other. They're joking around. They get to meet us. They get to meet their TAs. Now people are just sitting in their rooms with the door shut, doing nice experiments, but they don't get to know each other anymore. They don't get to know each other. They don't get to know us, and that's a shame. It's something I miss. So these are things that didn't work. They're, I think, mostly unavoidable, but it's still unfortunate. So I'll just want to end. I think we're about half hour in. Just end with my personal suggestions. If any of you are interested in doing something like this yourself, one thing is to be very clear in your intentions, and this is both for yourself and for your students. So what I mean here is I've been teaching this lab for 10 years, and some aspects of the lab just kind of exist momentum. Like, I've been doing this for 10 years, so I guess I'm going to do it again. Going through the lab forced me to go through every single experiment and ask, why am I doing this? What is the purpose of this question? What is the purpose of this thing we're teaching? And so forth. So to be very clear, why does this lab exist is important. It's also important for the students. Be very clear to your students. Why does this lab exist? Why are we asking you to do this? Why is this not just busy work? So be very clear in your intentions. It helps you to think clearly, helps communicate to your students. Keep things as simple as possible. All the experiments students are doing this year, even though they have 2 weeks to do experiments, and in person they only have 3 hours, I cut things down instead of expanding things. These students are overwhelmed. So I made the experiment as simple as possible, to be done as quickly as possible. I don't want to overwhelm anybody with this. And that also makes life easier for you. Don't get overambitious here. Give lots of time for submissions. Like I said, I've got labs open for 2 weeks. That's what I would strongly recommend. Students are busy. Don't try to get them to do something synchronous or even like 1 day deadlines. You got to give them tons of time. The last minute, but at least takes a little pressure off of some of them. The last thing is to start with something that is very simple or is very low stakes. So our very first lab this year was just data collection. Students had to drop a ball, time how long it took to hit the ground, fill out a data table, nothing else. The analysis was left for the next experiment. And by having something simple, that's how you solve all of your problems. That is how students learn about how to format the document, how to submit a file, how to attach a photograph, that sort of thing. It helps your teaching assistants learn, here's how you grade things. By starting off easy, that means that when you get into the second lab or third lab and things get interesting, you don't have to worry about learning the technical issues anymore. That has all been ironed out for both the students and the instructors alike. So that's about all I have to say. It's a little funny just talking to my computer and a couple cats in the background. So I hope this was valuable. Are there any questions? I will close my tab and we'll see if there's anybody else here. So, yeah, so we're back again. I hope you're all able to hear this. Are there any questions, any feedback? I see there's comments in the chat, so at least people did hear me, and I wasn't just talking into a void for half an hour. Yes, Jennifer.
Hey, Simon, thanks for that presentation. It sounds like you've done a great job, and I
hope so. We'll see.
I've got a few notes for biology. I have a couple questions for you.
Yeah.
The rubric thing, I've been kind of looking at the rubric thing has been on my to-do list for a while, and I'm just wondering sort of, did you have like document answer keys that you converted to the rubrics, and then how flexible are the changes? Like if you wanted to make changes to the rubric, set it up, how easy is it to do that?
So setting up a rubric in Brightspace is extremely easy, which is lovely. Well, you know, the first time is hard, and the second time is extremely easy once you learn what buttons you got to press. That's basically it. So, for example, like I was setting up our final experiment yesterday, and I had to set up a rubric and also a grading scheme to send out to my teaching assistants, more detailed instructions. And that took me maybe 10 minutes or so. Like, I know that with best practices, you're supposed to, like, you know, write everything out in a document and, like you said, you know, transfer things, but whatever. I just make it up off the top of my head, and it works out fine. So one thing that did help me is I decided early on a simple marking scheme that roughly matched what we did in person. So 40% of the grade is students' results. So that would be like data tables, calculations, graphs, that sort of thing. 20% is uncertainties, and 40% are discussion questions, just 4 questions. So it was pretty easy. I would just go through the lab report and say, well, here's 4 things we asked them to do, 1 point each. Here are the 2 main types of uncertainty, 1 point each. Here's my 4 discussion questions, 1 point each. Done. Now I have a 10-point rubric. Trivial.
Right. Okay.
So it worked out very well for us.
All right. Yeah, I'm gonna look into that for biology. And my second question is more sort of looking into the future.
Yeah.
Is there anything about putting these labs online that you would sort of keep after going back face to face? Or
I know. That's a good question. That's a good question. So some things that I do like. So right now, or well, not now, but in the past when we're in person, what we would do is we would give students a pre-lab assignment, which would be like a little homework assignment that requires them to read the instructions and all that, and come prepared. And it's been my experience that it doesn't really help at all. It's just a bunch of busy work for the poor students, and they come as unprepared as they always are. So one thing I'm thinking of doing is, just like I've been creating these little video introductions for the online labs, I'll just create 5-minute video introductions for the in-person labs and just post them and say, hey, just watch this video, and that's good enough. We don't need 3 labs anymore. Like, it's just a waste of time for most students. I would also like to think about if this rubric grading could be applied to in-person labs. Like, even if students are writing out by hand and submitting a document, which I still like, is there any way that we can just use some of these tools just to make marking efficient? Because it's fast. My TAs can mark real fast now, and that's kind of nice. Is there any way that we can just make their life easier?
Oh, maybe you could do that on Brightspace. Just keep the rubrics on Brightspace.
It's possible. Yeah, no, I got to think about that. But I just got to figure out logistically how would that work. Do my TAs have a stack of paper in front of them, and then they're also going on Brightspace, entering in things? Maybe they do. Like, I don't know. Maybe that's fine. I got to think about it.
Okay. Thanks.
Yeah, you could just have the students, like you say, take a picture of their written lab and then submit it the same way they do now on Brightspace.
Yeah. So I mean, like that's the other possibility. So when we do things in person, it's a 3-hour lab, and the student just submits their report at the end of the 3 hours. They hand it in and leave, and they have nothing to worry about. I could see a world where they submit their lab report like the next day online. That's possible. I don't know. Also, I just want to address a comment in the chat. A comment here from Jennifer talking about the one take. I promise you that they were all done in exactly one take. I am extremely lazy when it comes to this. I set down the camera, I press record, I talk for 5 minutes, I hit stop, and then I say good enough, and then we move on. Yeah, make a little mistake once in a while. Students don't care.
Fair enough. I'm still skeptical. One take and 15-minute dinners don't exist.
Yeah.
Hi, Simon.
Oh, hello. Yes, how are you?
Pretty good. How are you? It's been a while.
Yeah, I know. It's been a while. I'm busy, but can't complain.
Yeah. I'm now an instructional developer, a STEM instructional developer at the Mount. And thank you. And teaching physics and astronomy on the side. And we had a situation this year where I was not teaching the physics or the lab, but so we had a part-timer teaching the lab, and so she was not able to come in and do any kind of lab development essentially before the first day of classes. And so a group of us got together and put together a lab curriculum for this fall, and a combination of at-home stuff and some online simulations. But I loved your lab examples there. That was really well done. So I have a couple of questions for you. You said when you created that fillable form with Microsoft Word, the students struggled at first with that. Why did they struggle?
Some of them did. So what it is Microsoft Word creates a beautiful fillable form if you open it in Microsoft Word. And all students have access to Microsoft Word. It's free for all Dalhousie students. But of course, some students would try to open it in WordPad, or they would try to just open it in their, web browser or whatever else, and then things wouldn't work. Or they would attach photos, and for some reason, all of their photos would be, this long and this tall, and just, formatted incorrectly. Which is why that very first experiment was made to be just as simple as possible, just so that, like, hey, let's sort out these sort of issues on a lab that takes 10 minutes to complete. So if it takes 10 minutes to do the experiment and then 45 minutes to figure out how to submit the document, you're not panicking compared to like a 3-hour lab or something.
Okay. And my second question is, are you guys going back face to face in the winter? And if not, no, you're not.
No,
so how are you going to handle electricity and magnetism experiments?
That's an excellent question. So I will also say another wonderful advantage of these online labs is whereas traditionally we have a lab manual that we sell to students on day one with all the experiments in it. Because this is online, we only need to deliver this material week by week, which means that I've got no idea what to do about electricity and magnetism, but I only need to figure that out in February. As long as I can stay about 1 week ahead of the students, like we could survive. I only need to know like what we're going to be doing in January to start with. Yeah, electricity and magnetism is a problem. I think that I am going to have to go with simulation. There's some very nice simulations online, like, move around some point charges, measure the electric potential or field at different points, ask some nice questions about that. It's still interactive because students can, set up whatever distribution they want. They measure it where they want, that sort of thing. But, there's limits to what we can do. And I've got no idea what to do about magnetism. Absolutely no idea. So it may be the case that not everything translates. So we may just have to say, well, sorry, no magnetism lab this year.
Yeah. I know the Mount has given departments some leeway in deciding what to do in the winter on a limited basis in terms of, what about face-to-face stuff. And so some chemistry labs will be face-to-face, and our long-time part-time physics lab instructor has decided to go face-to-face. But the idea is then there has to be a plan B, right? If the place locks down again, then she's got to be prepared to go back to online. And those of us...
Like in our case, a large fraction of our students are just physically not in Nova Scotia and they can't travel here. So
that's right.
We're going to be 100% online in the winter and in the summer. And I'm not going to speculate about next September, but there's a chance, I think.
Yeah. Yeah. So I'm kind of dreading it because I'm not doing any physics at all this year, but I just hope, at some point, December 27th, the province locks down again and everything face to face at the Mount gets reverted back to online and nobody's got any physics experiments developed for the winter.
Yeah.
So it's kind of whistling past the graveyard, I think.
Yeah, that's fair. I mean, the thing that sort of goes unmentioned in all of this is a very strange situation for us to all be in, to be, developing new things. Like, maybe the best you can do is like 70% of what you normally do.
Yeah.
And in which case, like you say, well, it's fine. I'm going to do the best 70% I can. And I'm not going to lose a lot of sleep about not hitting like the same quality of teaching that I always do. Like, I don't know how we did this year. It's obviously not quite what we normally do. We are teaching less. The experiments are a little simpler. Students do miss out on these expensive equipment we have, but there's a ceiling. You come as close to that ceiling as you can, but you don't have a lot of control over where that ceiling is.
Yeah. Yeah, I totally agree. Well, thank you. This is a really good presentation. I learned a lot.
Oh, thank you. Well, we'll see what happens. The term's not over yet. I haven't got my evaluations yet, so let's hope that it actually worked. Excellent. Anybody else? I see some comments from Laura about rubbing balloons on your head, and that is something I thought about. I think that'd be fun. I got to figure out how to actually turn that into an experiment, but be interesting. That is at least electrostatics. I've got some ideas for the winter term. I thought about if students have this is hexagonal, but if students have a round glass, you could fill that with water, and now you have a lens. We can do an optics lab just like that, or a pop bottle, or whatever else. Maybe there's experiment that can be done with plane mirrors. You can talk about wave speed with water in a milk carton or something like that. Like, there are things that can be done. So we'll see. We'll see what comes.
Requires some creative thinking. But
Yeah.
it's really
interesting.
interesting.
I think that's fair. So I will say that when it comes to developing these experiments, creating a new experiment takes me about 1 day. So sitting down, writing the instructions, recording the video, doing the worksheet is about an 8-hour day. But that comes after weeks and weeks of thinking about it in the shower while cooking dinner, while going for a walk or what have you. So I've been thinking about what to do in the winter term basically since September. I've got enough ideas rattling around that I think I can come up with 3 or 4 solid experiments, and I've got a couple more at the very earliest stages. So that's the other thing I didn't mention. You need to give yourself an awful lot of lead time. Even though the actual work might be less, you need to give yourself a lot of just figuring out time, dead ends, that sort of thing.
Definitely. It's a lot of preparation. We can tell based on the materials that you showed us that there was a lot of preparation involved in that, but it probably saved a lot of headaches during the semester because everything was so well thought out and prepared.
Yeah, let's say prepared more than well thought out. That's not that much credit. But I will say that's the other advantage that I didn't mention in the slideshow is that right now labs take me, a day or two to prepare all of the material, videos, instructions, and all of that. I've got office hours 4 times a week. Of course, when everything gets submitted, there's a whole lot of panicky students to deal with, discussion board and all that. But the actual day-to-day workload for me is actually lighter than it is in person, because in person I attend every lab, so I'm physically in a room with students for 21 hours a week. And that just eats up time. I'm just answering the same questions again and again. It's not hard work, but it's like working on an assembly line at a factory or something. Just answering the same question 10 times per day for weeks on end. So it's a different kind of workload now.
Yes, time where you can't be doing anything else, for sure.
And also, don't get me wrong. I'm not just sitting around relaxing. I've got 20 times more work in other categories that's popping up at the same time. So yeah, I'm keeping nice and busy these days. Anything else? I think we got...
Yeah, does anyone else want to jump in with any issues that you're having, or even any solutions that you've implemented in your own courses?
I would love to hear what other people are up to, because I will say the other disadvantage of this is not only your students are isolated, but so are we. I got no idea what everybody else is up to. I don't know if I'm being innovative or if I'm doing the same thing 100 other classes are. So I'd love to hear what other people are up to, what's worked or what hasn't worked.
So Simon, I'm actually on a similar 2-week lab schedule as you. Yep. So that works well. I noticed all the same patterns for submission and all that stuff.
Oh yeah, that's always true.
And what I've done this term, I'm always flexible with deadlines if students request extensions, but I just tacked on a 24-hour grace period to every lab this term, and it's been kind of fun in a way, because I'll get my labs are due at 11:30 p.m. and I get emails from students the next morning. I couldn't submit my lab because this, that, anything. I'm just like, you can still submit it, just submit it, and it's it's good PR points too. I think a lot of them don't realize it's there, and then when they find out, it's just oh, awesome.
So, is this something that you're just doing, or is this something that Brightspace can do, or do you just set the deadline to be 1 day after it officially is?
So there's the due date, and then there's the end date or something. Oh. So it doesn't call it grace period technically, but it's so you can set the end date to be 24 hours after the due date, and so the due date shows up in the student's calendar, right, as this is when they should submit it.
So the end date is actually the final time to submit, and the due date is sort of the the big public.
Yeah, exactly. The end date is kind of when the Dropbox closes.
Oh, and I didn't know that. I've been just manually setting them to be equal for every single experiment. I assume that they were the same thing. Interesting.
Yeah. So, and it'll like give them a little flag. It'll say late or something, but I tell them I don't care about it. There's no
okay,
penalty.
well, I'll do that. I've got a lab due tonight. I will give them a little grace period without telling them, and maybe that'll save me some emails tomorrow morning.
Yeah, it might. Well, it might not save you the emails, but it'll give you some good news to return to them.
Yeah. Oh, that's good to know. Thank you.
Yeah.